All right, so let's continue our discussion of hybridization. So how orbitals hybridize depends on the bonding and the geometry of the atom. And so what we'll see is that it's actually more so the geometry rather than the bonding that determines the hybridization. So just some things to know is that hybridized orbitals form sigma bonds. Gets the Greek sigma symbol. And in this type of bonding, we have direct overlap of the orbitals. And then non-hybridized orbitals form pi bonds. And here we have indirect overlap. So let's take a look at our first hybridization scheme, and that this is Sp3 hybridization. And so let's take a look at what this means. And so the fact that there's four kind of letters here, or four orbitals, one S and three Ps, indicates that there's kind of four zones or four things of electron density, right? So this can be other atoms or lone pairs. And again, the Sp3 also tells you that it's hybridization of one S orbital and three P orbitals. So for example, right, we have our S orbital looks like a sphere, and then we have our three P orbitals that look like dumbbells, right? And then they all mix together to form four Sp3 orbitals. And the way that these Sp3 orbitals look like is they all combine to make a tetrahedral shape. So we've got one orbital going up, one to the left, one kind of coming out of the board, and then one going into the back of the board to form a tetrahedral shape. So this is four separate Sp3 hybridized orbitals. And so one of these Sp3 orbitals looks something like this, right? It's got a big dumbbell, and then it's got a little tiny end on the other side. So all of these guys have this, so there's like a little one there, but they're not often shown, right? So the top picture is four Sp3 orbitals combined. The bottom is just one Sp3 orbital. And so let's see how this occurs in the bonding of CH4, right? So if we think about CH4, it's got four atoms attached to it, right? 1, 2, 3, 4. So this carbon will be Sp3 hybridized. And so if we think about carbon, we got these four Sp3 orbitals. Carbon has four valence electrons, so there'll be one electron in each of these orbitals. And so we can draw our carbon with its four Sp3 orbitals, with one electron in each one of these orbitals. And then we have hydrogen. Hydrogen just has its one S orbital, and so it's just kind of a sphere, and you can see that then there's overlap here. And so we can see how these hybridization predicts this tetrahedral shape, right? So if you think about the shape of this carbon, right, hydrogen up top, hydrogen on the bottom, hydrogen coming out of the board, and then hydrogen going back into the board. And all of these are direct overlap. And so these are all sigma bonds. All of these are sigma bonds. And we can think about other compounds as well. Ethane, right? 2 carbons with a bunch of hydrogens attached. This looks something like this. Right, both of these carbons are sp3 hybridized. So we can draw a carbon, carbon. Here's one sp3 orbital, the other sp3 orbital from the other carbon, and then 1 electron in each. And then each one of these carbons has 3 more sp3 orbitals. So one like that, one going out of the board, one going back into the board, one like that, one going out of the board, and then one kind of going back into the board. And then there's a hydrogen on each one of these. And so what you can see here as well is that we are free to rotate and still have complete overlap, right? If this compound is spinning, it can still overlap, right? And all of these are sigma bonds. They're all direct overlap, right? And other atoms other than carbon can hybridize, right? So atoms other than carbon can hybridize. So let's take a look at some of these, right? If we think about ammonia, NH3, remember that this has a lone pair. And so again, this nitrogen will be sp3 hybridized. It has 3 atoms and 1 lone pair. That's 4 things attached. And then if we think about these 4 sp3 orbitals, nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. We see one of these sp3 orbitals is filled, right? And that represents nitrogen's lone pair. Right, that's nitrogen's lone pair right there. Then each one of the other sp orbitals only has 1 electron from nitrogen. And then the other electron is supplied by the hydrogen. Right, and then we get our trigonal pyramidal complex right here. Water as well, kind of same thing here. If we think about water, water has 2 lone pairs, and so it's also sp3 hybridized, right? 4 things, 2 atoms, 2 lone pairs. If you think about oxygen, it has 6 valence electrons, so 1, 2, 3, 4, 5, 6 valence electrons. And so if you draw oxygen in the middle, you would draw it with 1 lone pair is totally filled, or 1 sp3 orbital is filled. Another sp3 orbital is completely filled, and then it's got 1 sp3 orbital going out of the board, 1 kind of going back into the board, and then these 2 can form their bonds with hydrogen. So it all makes sense. Again, all sp3 hybridized atoms have 4 things attached. Right, so again, this NH3 example, each hydrogen 1, 2, 3, and then the lone pair is the 4th thing. In water, you have 1, 2 hydrogen atoms, and then 3 and 4 for the 2 lone pairs. And then of course, carbon has 4 hydrogens attached, right? So you can figure out the hybridization simply by how many things are attached to your atom.